Hi guys, in this video we're going to have a look at probability and all the different types of questions. Now there's lots of different types of probability questions, and even after you've watched this you want to try and get your hands on as many as you can because they're very different. So this is the basic form. So basically there's a spinner and it's being spun and it has the sides 1, 2, 3 and 4. So an experiment has taken place and we found out that the probability of landing on a 1 is 0.2, the probability of landing on a 2 is 0.35, we don't know the probability of 3, but we do know the probability of 4. And they're asking us, what is the probability of 3? So they're basically testing your ability to know all probabilities must add up to 1. So if we work out what this is, our remainder must be equal to 1. So 5, 6, 0.7... 8, I make that. Let me just check that. So 5. No, that's absolutely wrong. That's 0.73, and that's wrong because I wrote that for some reason. So if that's 0.73 combined, this bit must be the difference that makes 1. So 1 take away 0.73 is 0.27. Now in part B of the question, it says, if you were rolling or spinning the spinner 400 times, I should have written there. If you did it 400 times, how many 3s do you think we're likely to get? So this is what we're likely to get after 1, so it's not likely to be a 3. So all you have to do is, if you know the probability, just times it by how many times you're going to do it. So 400 times 0.27 is 108. So that's the same on all these types of questions. If you know the probability, just times it by how many times you're going to do it. Now, a bit harder is tree diagrams. So here we're told that this lady called Jill is going to play 2 matches, 1 tennis match and 1 badminton match. Sorry, I should have written that in there. And we're given this information. We're actually given the tree diagram. So we're told the probability that she wins a tennis match is 1/4, and the probability she wins the badminton match is 2/5. Now you need to understand that all of these add up to 1. So if that's 1/4, this must be 3/4, and again here. So that's 2/5, this must be 3/5. So the outcome of this match isn't affected by this one. So that's why here it's just going to be the same. Whether she wins the tennis or loses the tennis, it's going to be exactly the same. They don't tell us that, but they don't tell us that it will affect it. So just repeat them. If you think about it, whether she wins or loses, if they're one after the other, she's going to be tied either way, so it's not going to make any difference. So that would be like 2 marks, for example. Then it might say probability of winning at least 1 game. So here she wins both, so that is at least 1. Here's a win and a loss, so that's also at least 1. Here's a lose and a win, so that one is at least a win once, but she loses 2 here, so we're not interested in this outcome here. So 1/4 and 2/5. And when we're going along or saying the word and, we always multiply our probabilities. So this one again, so 1/4 times 3/5. And lose and win, so that's 3/4 times 2/5. So times and fractions, 2/20, 3/20, and 6/20. Just remember it's times the tops and times the bottoms. So this is the 3 possible outcomes. So it's that one or this one or this one. You can tell I've changed my words. That and that, we multiplied. This or this or this, we're now going to add these together. So 2, 5, that's 11 out of 20 is the probability. So just over half chance. This one, however, is slightly harder. So imagine there's sweets and they're all in a bag. And someone, like Danny, is dipping his hand into the bag and picking out a sweet at random, eating it, and then he takes another. And we're interested in what's the probability that's different. So the first choice he has is orange, red, or green. So if he takes an orange, well, there's 4 out of 9. The red, there's 2 out of 9. And the green, there's 3 out of 9. But this is the bit that's important. He now eats it. So if he has an orange, there's only 3 oranges left, and therefore 8. So then a different one will be 5 over 8. If he has a red first, then there's only one red left. So that would be 1 out of 8. And the different colours, there will obviously be 7 out of 8. Let's move it down a bit now. So if he has a green again, there will be 2 out of 8. And the different one will be 6 out of 8. So what is the probability it's going to be different? So we're interested in this outcome here. Red and then a different one, and green and a different one. So 4/9 times 5/8, 2/9 times 7/8, and 3/9 times 6 over 8. So I'm going to do this bit quite quickly. So it's this way, or this way, or this way. So we have to combine all three of these. So 20, 32, 52. So the answer is 52 out of a total of 72. This is called conditional probability, and that's an A. You might have to look a few of those up to practice, but like I said at the start, get your hand on as